Alright, we're getting into chapter 8, section 2 now. This would be the first one. I guess it would be 8.2a. The first day of our work is just going to deal with multiplying a monomial by a polynomial. Remember, mono meaning one, means you're taking one term by a series of terms. Also, again, as I guess it says here, recall that a monomial is a single term. This process is best described as the distributive property, which we already know, on steroids. So in other words, they take something that was very easy, and all they're going to do is make it a little bit more difficult, a little bit more challenging, to represent the fact that this is your second semester of Algebra 1 and that we should have skills kind of under control. We have done the following problems before. This is the one where you say to yourself 5 times x is 5x. 5 times 7 is 35. That's how good we got at it, to where we could just kind of multiply it straight out. Same thing here. 3 times 2x is 6x. Minus 3 times 6 is 18. These two are easy. This is tricky, and again, the trick you need to keep in mind is that they like to put negatives on the outside to make sure you mess up. So if you are taking the shortcut, which today I wouldn't recommend it, but if you are doing that, make sure you factor in the negative. This is negative 4 times 5, which is negative 20x. And then you have a negative 4 times a negative 3, which is a positive 12. But again, we've done the distributive property before. It's just that today we're going to have terms that are a bit more intimidating. It doesn't mean you won't be able to learn any better. I just want you to, again, have an idea of what's coming up. The general idea, kind of like when we did exponent rules, it breaks down to 3 steps. And if you memorize these 3 steps, and I'm going to talk through this every single time, identify the sign, because that's the most important part. Determine if it's positive or negative. Sometimes it's going to be obvious, kind of like when we did this. I didn't have to say this is a positive 5 and a positive 35, a positive 6 and a negative 18. I did have to say this is a negative 20 and a positive 12. So first off, make sure you always slow down to identify the sign. Second, you multiply the actual numbers. And third, what we're going to do is count the variables. So they're really not tough steps. It's just something where you have to practice it enough that it becomes natural for you to do. Because you've already learned how to do the distributive property, there really is nothing for me to teach you. So we're going to spend the rest of the time learning from mistakes as you practice. Keep in mind, you're going to make mistakes today. I think I've heard at least 15 students tell me that they're afraid to mess up. But I mean, you're in math class. Math class is kind of like building a house. If the first time you build a house, you're not going to do it right. The house is something's going to mess up. So just accept the fact that you're going to make some mistakes. But if you open up your mind to be sure to look for why you're messing up, which is what I'm saying here, you can actually identify where your mistake is and kind of stop yourself from making it. So other than that, let's start with some problems here. Again, I'm going to do this the long way because I need to make sure that we know what we are doing. And I suggest, at least for your notes, that you do it this way. Don't get lazy. Again, just write down whatever it is. So here, 5n meets 3n to the third. And I will always use a plus. 5n meets negative n squared. So it's not tough. You just have to now take each part, and again, you know it's positive, so we don't need to worry about that. The numbers are 5 and 3, which make 15. But here's where I said count the variable. I've got 1 n here, 3 n's there. It should be 15 n to the fourth. This is the only time that the variable changes because we are multiplying. Remember when we were combining terms, they don't change. But whenever you're multiplying, you're saying 1 n here, 3 n's here, make 4 n's. I put a plus, but I don't think I should have, because when I look here, you have a positive times a negative, which means I should have put a minus. The only number here is 5. I have 1 n here, 2 n's there, so it should be minus 5 n to the third. I kind of made that mistake naturally, but like I said, what happens is whenever you're doing it, you don't want to put plus. You want to kind of see what the sign is before you put the sign. But 15 n to the fourth minus 5 n to the third is what you end up with. B. Even though this is back here in the back, you are still saying that 10 is going to meet 3m squared. And, which means plus, 3m is going to meet 3m squared. And so again, we know this is positive, so we don't need to worry about it. 10 times 3 makes 30. The only thing I see in this meeting is 2m's. Plus, because that is positive, 3 times 3 makes 9. 1m here, 2m's there, make 3m's. And that's all you have to do. Alright? So again, not so bad. Not that tough, just take your time. C, this is where they expect you to mess up, so you definitely want to slow down. You have a negative w squared meeting w, and, which means plus, we have a negative w squared meeting negative 15. So looking at the sign, you have one negative in this group, which means it's negative. There are no numbers, but there are 3 w's. Again, if there are no numbers, you don't need to bring one down. Here, these 2 negatives are going to make it a positive. The only number we have is 15, and we only have 2 w's in the problem. So it should be negative w to the third from that, plus, because that's positive, 15w squared. Looking at this one, this is just going to be 3 meetings. You have negative 4x to the third, meeting 2x to the third, and negative 4x to the third meeting negative 7x squared, and you also have negative 4x to the third meeting x. And so now all you have to do is simplify 3 of these things. The sign here is negative. The number would be 8 because of 4 times 2. I've got 3 x's and 3 x's, which makes 6 x's. I look here and recognize that a negative times a negative makes this next part positive. 4 times 7 is 28. 3 here, 2 there makes 5. Last part, I have 1 negative, which makes it negative. My number is going to be 4. I have 3 x's here, 1 x there, which makes x to the fourth. And again, that's all you're doing here, is just making sure you understand how to put this stuff together. Last one here, not last one, but another one here, just ugly here, negative 5y squared meets negative 3y to the third, and which means always use a plus to connect it. Negative 5y squared meets 8y. From there, negative times a negative is going to be positive. 5 times 3 makes 15. 2 y's and 3 y's make 5 y's. Here we have 1 negative, so it's going to be minus. 5 times 8 is 40. 2 y's here, 1 y there make 3 y's, and that is your answer. No, you don't notice it because it's becoming more of my natural step, but notice that I am kind of saying, what is the sign going to be, what is my number going to be, and counting the variables that are there. Again, notice that whenever I do it, I'm kind of saying this is going to be a positive, and then I don't look at this as negative 5 times negative 3. Once I know it's positive, I just say 5 times 3. Just like over here, once I know it's negative, I don't see negative 5 times 8. I have the minus, and then I just say 5 times 8 is 40. So it's what's the sign, what's the number, how many variables. And you just continue that process every single time. F, 3xy squared meets 2x, and, which means plus, 3xy squared meets negative 4xy. Notice that that is a negative 4, and, which means plus, 3xy squared meets negative 5y. And all I have to do now is make these things multiply through. What is the sign? It's positive, so we don't need anything. What is the number? 3 times 2 is 6. Now you count your variables. There's 1, 2 x's, but there's also in this case 2 y's, because there's an x here and an x here, so there's 2 x's, but there's also a y squared. What's the sign on this? It's going to be negative. What's the number? 3 times 4 makes 12. Count the variables. Again, I'm doing the same thing over and over. What's the sign? What's the number? Count the variables. There's 1, 2 x's here, 2 plus 1, 3 y's, and that would be my second term. What is the sign? Negative. Number, 3 times 5 is 15. Counting, I have only 1 x, but I do still have 2 plus 1 or 3 y's. And that is all that I have to do. I don't think you should have any like terms on this because there's no like terms here, and so it ends up, you might want to check, but like I said, it's nothing really coming down from that. So before moving on to the class practice, let's review that idea of finding the GCF. Let's keep kind of zeroing in on that, because it actually is very important tomorrow, because it's the first step that we're going to have to make in terms of answering questions. What I'm going to teach you, and like I said, on the video I did over the weekend, I kind of gave you make the table for both numbers and then find the biggest number. I also showed you how to do it on the calculator. So I'm not going to do those two today, because if you've already mastered the process for finding the GCF, go ahead and work on finding the GCF now in your way, and then see if it matches what I do. But listen carefully, especially if you're the factor table person, because you don't have to always make two factor tables. I did that as the example, but you really don't have to. Really, the best way to do it is to think for a second. And as I say, work smarter, not harder. Would you like to make two tables of big numbers, or would it be better to make one table of a smaller number? I think it's easier just to make the factor tree for 16. And so we go to 16 and we say 1 times 16, 2 times 8, I believe is 16. 3 doesn't go, but I think 4 times 4. And once I see that that matches, my table is done. Now here's what I do. You simply use these numbers to check into 48. So I check 48. I say 48 divided by the biggest number, which is 16. Notice that it works, and so that means it's 16 is a GCF. So it's that simple. Again, you simply make the tree for the smaller number because it should be less work, and then you take from the biggest to the smallest. If 16 didn't work, then we'd check 8. If 8 didn't work, we check 4. If 4 didn't work, we check 2 until we find a number that goes into both. Find the GCF of x to the 5th and x to the 3rd. Again, on the video I showed you earlier before the weekend, I told you that this is like two people with money. I want to charge the most that I can without overcharging to where both of them can purchase. In other words, what do they have in common? Or what is the lowest amount? And both of these have 3 x's in common. Because this has 3 x's, that has 3 x's. So x to the 3rd would be your GCF. But again, typically for GCF of a variable, you choose the lowest amount of the two. So again, that's kind of something you're going to have to kind of get ready for, keeping in mind that tomorrow this is going to be a major part of what we do. And tomorrow what they're going to do is they're going to put numbers and variables together, so you have to kind of take your time. I don't think we need to make a factor tree for 10 and 8. Think about the biggest number that you can possibly think of for 10 and 8. I think it's 2. You might want to check 4 just to make sure, but 4 doesn't go into 10. But 10 and 8 can both be divided by 2. And then you look at your x's and you say, how many x's do they have in common? Again, what is the lowest amount of the two? 2 x's here, 1 x there. It means that they have 1 x in common. And so your GCF would be 2x. The reason I did not do anything for 10 and 8 is because I think they're small enough that I don't need to make a tree for that. But if you need to, that's fine. But when I look at numbers like 24 and 18, I don't try to do those in my head. I would rather go ahead and make the tree for the smaller number, which is 18. 1 times 18, 2 times 9. If I'm bad with this, I simply do 18 divided by 3 to see that it is 6. 4 I don't think goes, but let me check. 18 divided by 4 is a decimal, so no. 18 divided by 5 I'm pretty sure doesn't go, so no. And the reason I stop is because my next number is 6, and 6 is already in the list. Now what I do is check it with 24. Can 18 go into 24? I don't think so. I'm pretty sure it does not. I definitely know 9 doesn't go into 24, but 6 does, which means that my GCF number is 6. And notice how just making this and then checking this list actually works for you. And then in terms of the variables, how much do both of them have in common? Or in other words, what is the lowest amount? And the lowest amount is x to the 3rd. So again, this is going to be a key skill tomorrow. Make sure you take some time to get all this stuff down, get some practice, and at the end of the hour we'll go over some of these answers. But again, work to get it. Please fix that error where you keep saying that you're forgetting what you're doing because you're too old, you're too grown to be doing that. Please stop doing that. Forgetting is not an option. Just like I tell somebody else, quitting is not an option. You have to keep moving. So good luck on this. Get some help. Work together quietly, but make sure you're working. There we go.